Hi, I'm Jerry Cotter. Welcome to EarthX. And I'm here today. I've retired from the Corps of Engineers last summer, and I'm now with the University of Texas Water Engineering Research Center. At the Corps, I spent about 34 years there. We operated the reservoirs across Texas, did a lot of flood science studies and mitigation projects across the region, and also dabbled in water supply as well. Dallas-Fort Worth is an incredibly important region in the country. Of the 195 countries across the world, Texas is the 9th largest economy in the entire world. And Dallas-Fort Worth generates about 1/3 of that economy. Additionally, the population of Dallas-Fort Worth, when I came here in the mid-'70s from West Texas, the population was about 2.4 million. It's now more than tripled to 8.4 million. And we're scheduled to reach around 12 million in 2055. So incredible growth, incredible economics in the area. I'm going to go ahead and pull a slide up here, I think. Yes, well, maybe not. Okay. We're located in the Trinity River watershed, and that watershed is about 8,100 square miles draining down to DFW. So there's a lot of potential for flooding in the Dallas-Fort Worth area. Additionally, we're located at the confluence of 4 major tributaries of the Trinity River. So we picked the lowest area we could, the most vulnerable area, and that's where we built our city. That's the way it works. Every drop of precipitation that happens in this watershed has one location to exit the system, and that is south of Dallas. There are no other exits for that water, so it's extremely important that we store water in the watershed during extreme flooding events. We are not doing a great job of that, and we'll talk about that in a moment. But kind of an anecdotal story, in 2015 we had some really severe flooding across the region, and we filled up completely the 6 flood mitigation reservoirs that protect the area. They're shown on the graphic over here. The blue basins are those flood mitigation reservoirs. It took us 4 to 5 months to empty those reservoirs safely after that flooding event. That's because there's very limited capacity to move water out of the river system and down south to the coast. And any extreme precipitation event that happens, it takes a long time for that water to move off. The reservoirs on this map also supply the water for the region. We're mainly on surface water in the urban developed area. However, in the areas out on the fringes, we're still on groundwater. But that water supply, even though we've developed those 6 federal reservoirs and several other state-owned reservoirs, we still don't have enough water to currently supply DFW. So we're piping water from East Texas and Northeast Texas to the region. There are plans for new reservoirs to be built, and that's all going to be piped in. There's really not any opportunities to build new water supply reservoirs here. As we start to move to server farms and the water demands even go up from there, we're going to have to practice conservation. So in DFW, we design infrastructure for about 10 inches of rainfall in a 24-hour period. And normally, that's probably fairly adequate for most infrastructure. But between 2009 and 2020, we received over 20 storms that exceed what we design infrastructure. And that's the dots you see, the X's to the right side. Those are all above what we design infrastructure for. Normally, we get 1 to 2 of those events per decade. But during that active storm period, we actually had over 20 of those events. It turns out that this is a cyclic thing. Back in the 1930s and 40s, we also saw a really active storm period, as you can see from the red dots, where we received extreme precipitation in the area. So we're not doing that great of a job. In 2015, 2016, and 2017, we had 156 fatalities, over $100 billion in damages. Extreme precipitation. Patricia, that you see on this chart, the third one down on the blocks on the upper right, that storm was 25 inches in 24 hours, and it hit just 50 miles south of DFW. That could have easily hit the DFW area. In 2010, Tropical Storm Hermine hit the Rush Creek watershed in Arlington, and that wasn't even a 100-year storm. It was during a drought. It was a smaller storm, and that resulted in $17 million in buyouts. So that tells us that we're not really doing a great job of managing flood risk. Flood risk happens for a while, then it doesn't. People forget about it, but it's important to stay focused on this. And again, that black line, that's what we're designing infrastructure for. All of those dots are storms that exceeded that infrastructure design. There was a convective event down in near Somerville and Brenham. That event dropped over 20 inches in 24 hours. And that is very unusual to get a convective event that produces that type of precipitation. I don't know if they didn't get the animated version, but this slide normally plays those storms as they happen in the location they happen. But you can see from the coverage, if you're in central Texas on over, you're very subject to these storms. The lower, really dark, is Hurricane Harvey, and that was the largest storm that ever hit the United States, with about 60 inches of rainfall, and geographically the largest storm in our history. I went down and worked that storm at the Emergency Operations Center, did the inundation mapping, but we showed that 60% of Houston was underwater, about 25% greater than a foot. So that tells us that, maybe we need to do better. So growth and development increases flooding. And what happens here, as you can see from the plots, we pave the area. We also encroach into the river system. We cut down the trees. And what we're doing there is we're shoving the water off of the property as quickly as we can. And as I talked about earlier, what's the important thing? Storing that water till you can safely have it exit the system. We're not doing that. We're pushing it down on the downstream. Who is the furthest downstream? Dallas. So we have big levees there, but there's still a lot of unprotected area that will be subject to this flooding. So encroachments into the stream itself, there's in the National Flood Insurance Program, you're allowed to encroach into the floodplain and fill that in to something that's called the floodway. And we're commonly doing that. There are a few cities that have set policy to stop allowing this to happen, and this depletes that storage, and so we're just worsening flood conditions as we go downstream. You can see on the left side of this graph, that's the Trinity River during a flood in 1990. It's spread out for a mile wide. We do have a program that we started in the 90s that protects the storage in the main stem of the Trinity River. That program is the environmental impact statement that showed the need for that was done by the Army Corps of Engineers, but the program was taken over by the Council of Governments, but it's really driven by internal ordinances of each of the communities along the Dallas-Fort Worth, or along the Trinity River. Who knows how many communities are in DFW? Any guesses? Over 170 cities. So you can imagine it's like herding cats. And the Council of Governments is really that organization that tries to bring these governments together in a planning effort to plan for the future. So this program is very successful. You can see from the pie chart, the blue area is what would be stored in that main river during a major flood. The other slices are what's in the reservoirs. You can see that the river stores more water than any of the flood reservoirs. In fact, more than 2 of them. So what are we going to do differently to prevent these bad things that have happened, to be able to accommodate these things? We have a project for the western half of the DFW area. The lead organization is the Council of Governments, but the Corps of Engineers is a partner. Tarrant Regional Water District is a partner. Dr. Jabber's AgriLife group is a partner. And we're all working in that 7-county area, 85 cities, to plan stormwater infrastructure in conjunction with transportation planning. Transportation is really where the money is. It's where the attention is. You know, we all get pretty upset when we're sitting on the freeway, and so that gets the attention. Flooding just happens here and there, and unless it happens to you, you generally don't get upset. So it's very important to have that partnership. But what we'll be doing is we are building numerical models for that entire 7-county area, and we're evaluating existing conditions, 2070 conditions. We're also doing some alternative hydrologic loading by taking these larger storms and applying those and seeing what they would do. But we hope what comes out of this are policy shifts, protecting riparian zones of streams, also identifying the importance of storage and developing that storage. Through my 45-year career, I've mainly gone into areas and fixed flooding problems. I can tell you from I'm really 29. I just look 67 because of all those flood mitigation projects that I've been involved in. That's not the way to go about it. The way to do it is to proactively plan rather than react in the future and transfer that debt to future generations. So this is a fantastic project. We need everyone's support. We need you all to get behind this project, because we're not just looking at storage for floodwater. We're looking at wetlands. We're looking at urban forest, urban prairies. We're looking at recharging groundwater, just at many environmental purposes. And we're bringing in green infrastructure as well, which helps to clean the watershed. It captures some of that first runoff and tends to clean that. Wetlands are also really wonderful because we can put our wastewater effluent into those wetlands and we can further improve the water quality of that effluent. So this study is about halfway finished. We've got about 2 years left. It's a $10 million study. It's really why I came out of retirement. I retired last summer, but this is a project that I was one of the architects for, and that is a real passion for me, and I want to see this taken to fruition. Another important reason to consider projects like this that suggest that open space is important, trees are important, is in 2021, who remembers the heat dome that hit Portland, hit Oregon, and hit Washington? Could you imagine the maximum temperatures in Portland were 124 degrees in the urban area? I usually think of going to Oregon to cool off, to get some fresh air coming off the Pacific, but in this instance, 124 degrees. So there is a professor out of Oregon State who went around and took temperature samples, and he published a study. In the areas that had tree cover, the temperature never exceeded 99 degrees. So those trees can make a tremendous difference. Why is that important for Texas? Last summer, what happened that was very unusual? New records. We reached 2 days of 110 degrees. We had a couple of, a long week of a really hot spell. As a result, we're seeing an increase. That graph at the lower left is the heat-related fatalities in Texas. Those are on the increase. Now, part of that's driven by population increase, but definitely the warming temperatures. And don't just look at the averages. We've done basin studies that show the averages are up 1 to 2 degrees Fahrenheit, but the maximums, that's where you want to watch and see those major temperature shifts. And that's what creates the dangerous temperatures. In Portland, in that northwest, they had about 600 fatalities during that heat event. In Texas, our fatalities are increasing every year. As you can see, that graph is going up. So it's really incredibly important that we look at opportunities to engineer with nature, to preserve urban forests, to establish tree cover, to establish storage for floodwaters. And I would just ask you to reach out to your elected officials, to your community leaders, and advocate for these projects, advocate for these shifts and the ways of doing things differently. All right, thank you very much.